Have you ever wondered what secrets the universe is hiding? Out there, in the vast cosmos, lies a world of infinite possibilities, a world that has been the subject of our curiosity and exploration for centuries. We've barely scratched the surface, and yet our understanding has grown exponentially. Today, we'll be diving into some of the most momentous astronomical events in history, events that have shaped our understanding and perception of the universe. Prepare to embark on a journey through time and space. Our journey begins in the 16th century with Nicholas Copernicus, a man of many talents, astronomer, mathematician, physician, and more. But it was his revolutionary idea that truly shook the world. This idea was heliocentrism, a theory that proposed a sun-centered universe rather than an Earth-centered one. Picture this. For centuries, humanity had believed in geocentrism, the theory that Earth was the center of the universe, with the sun, the moon, and the stars all revolving around us. It was a comforting thought, wasn't it? To be at the center of it all. But Copernicus dared to imagine differently. He proposed that the sun was the true center, with Earth and other planets revolving around it. This was a radical departure from the accepted wisdom of the time. It challenged the status quo and shook the very foundations of how we understood our place in the universe. But Copernicus was not deterred by the controversy. He firmly believed that the natural world was mathematical and orderly, and heliocentrism, with its elegant simplicity, fit this belief. His idea, though met with resistance, began to gain traction. It sparked debates, inspired further research, and gradually changed the course of astronomy forever. And so a new era of understanding dawned, an era that would see the birth of modern astronomy, the discovery of new celestial bodies, and a deeper understanding of our universe. All thanks to Copernicus's daring vision. Copernicus's vision laid the groundwork for future astronomical discoveries. Fast forward to the 17th century, when another significant event took place. Our story takes us to Italy, where an innovative mind was about to change our perception of the cosmos. Galileo Galilei, an Italian polymath, reinvented the telescope, giving our eyes a new way to explore the heavens. Galileo's telescope was a simple device, but it was powerful. It magnified objects up to 20 times, a feat unheard of in those times. With this device, Galileo could see the craters of the moon, the rings of Saturn, and the moons of Jupiter. His observations provided a new perspective on our place in the universe. The moon, our closest celestial neighbor, was revealed in stunning detail. Galileo's telescope showed a rugged, crater-filled surface, contradicting the belief of a smooth, perfect sphere. His observations of Jupiter were even more groundbreaking. He discovered 4 moons orbiting Jupiter, proving not everything in the cosmos revolved around the Earth. Galileo's telescope also strengthened his belief in heliocentrism, the idea that the Earth and other planets revolve around the Sun. His observations of Venus's phases were consistent with this model, further challenging the Earth-centered view of the universe. Galileo's telescope was more than an invention. It was a tool that expanded our understanding of the cosmos, challenged established beliefs, and ignited a spark of curiosity that still burns today. Galileo's telescope brought the stars a little closer to home. Now, let's jump to the 20th century, a time of revolutionary theories and discoveries. One of the most significant theories to emerge during this time was the Big Bang theory. This theory, which describes the birth of our universe, was first proposed by a Belgian physicist named Georges Lemaitre. Lemaitre suggested that the universe began as a singular point, an infinitesimally small, infinitely hot, and infinitely dense entity, often referred to as a singularity. This was not just any ordinary point, mind you, but a point from which the entire universe sprang into existence, approximately 13.8 billion years ago. This idea was revolutionary, to say the least. It suggested that our universe has not always existed, but had a definite beginning. From this singularity, the universe has been expanding ever since, like a balloon being blown up. This expansion is not just of matter, but of space itself. What's fascinating is that the Big Bang theory is not just a theoretical concept. It is supported by a wealth of observational evidence. One such piece of evidence is the redshift of distant galaxies. When we observe the light from distant galaxies, we find that their light is shifted towards the red end of the spectrum. This phenomenon, known as redshift, suggests that these galaxies are moving away from us. The further away the galaxies, the greater the redshift, indicating that the universe is expanding. But it's not just about the redshift. There's also the cosmic microwave background radiation, the afterglow of the Big Bang, if you will. It's a faint radiation that permeates the entire universe, further corroborating the idea that our universe originated from a hot, dense state. From a single point to an infinite universe, the Big Bang theory continues to shape our understanding of the cosmos. It paints a picture of a dynamic, evolving universe, one that started with a bang and has been expanding ever since. This understanding has opened up new avenues for exploration and continues to challenge our perception of the universe and our place within it. In the final leg of our journey, we arrive in the late 20th century, a time of great technological advancement and scientific discovery. Among the most groundbreaking of these discoveries was that of exoplanets, planets that orbit stars outside of our own solar system. The concept of exoplanets had long been contemplated by astronomers, but it wasn't until 1992 that the first confirmed discovery was made. Astronomers Alexander Wolszczan and Dale Frail announced the detection of two planets orbiting a pulsar, an incredibly dense, rapidly rotating star. These were no ordinary planets. They were the first confirmed exoplanets, forever changing our understanding of the universe. This discovery was monumental for a couple of reasons. Firstly, it expanded our perception of the cosmos, proving that our solar system was not unique in its ability to host planets. Secondly, it opened up a new frontier in the search for extraterrestrial life. If there were planets outside our solar system, could there also be life? Since that initial discovery, more than 4,000 exoplanets have been confirmed, each with its own unique environment and potential for life. Some of these exoplanets are gas giants like Jupiter, while others are rocky worlds not too dissimilar from our Earth. There are even super-Earths, planets larger than ours but smaller than the smallest gas giants. The exploration of these distant worlds continues today, with missions like NASA's Kepler and TESS spacecraft dedicated to finding and studying these celestial bodies. The more we learn about these exoplanets, the closer we get to answering that age-old question, are we alone in the universe? As we continue to gaze at the stars, who knows what other secrets the universe has in store? What we do know is that the discovery of exoplanets has forever altered our view of the cosmos, showing us that we are but a small part of a vast, ever-expanding universe.